Hi, friends. This is Ray Lutz with Citizens Oversight. I wanted to go over this kind of important misunderstanding that a lot of people have. And you'll see these analyses being done by many people. And the latest one is from the group at ordros.com, I think it is. And they have this tool that is that does analysis of cast vote records. And let's see here. So you should be seeing here an analysis that they've done, and that I want to point out what the mistakes are or what the misunderstanding is. I don't think people are actually actively, trying to misrepresent things. But what they're doing ends up doing that because they get a few things wrong. And this tool that they have, which I'm looking at the Drazabot CVR Analysis tool. And you can read this in, and then they analyze the CVR. And here, what they're looking at is, in their example video, a case where they say, well, this is where if you were randomly sampling this population, you would be within this range. And I'm not sure where they're getting these red lines, but this is somewhat representative of, like, if you went out and did a polling of people in the community and you said, well, you would say how, which candidate will you likely vote for? And you see these all the time. They polled so many people, and there's an error margin of plus or minus so much percent. And that's the difference typically between these bars. And what I usually see is it expands way out at first and maybe doesn't quite converge as fast. But the other thing is, well, so that's what these are. And then this apparently here is the actual current, margin of victory as the votes. What they represent is over time, as you go through time, these votes go up first, very much in favor of Trump, and then come down, and until finally you get here. So in this respect, to them, it looks kind of fishy. So let's see what they actually are saying here in this section.
This time, let's look at the election from the end to the beginning. Evidence shows that in counties showing this pattern, the votes at the end likely provide the best representation of the actual will of the voters. Looking at it this way shows Trump with a huge lead that appears to be stabilizing around 270 until the effect of the manipulation causes the ratio to plummet over 100 ratio points. The red cone shows whenever you are looking at only myelin votes, which should be received and counted randomly. Any ratio significantly outside of that cone can be considered a possible fingerprint of fraudulent votes. Switching back to the front-to-back order, the ratio line does not get even near the expected cone until the very end. This is the Mesa pattern, and nearly identical results can be seen in many counties across the country.
Okay, and the reason for that is something that is a complete misunderstanding here. First of all, they're saying that they're taking this from the end to the beginning, and then they're acting like something happens over time. Well, first of all, these numbers down here apparently are the ballot, ID numbers as they go through. And this would be the very last ballot ID number in the set. So if you were looking at these red lines, they should come down completely to zero, because as you get to the very end of the population, you would have sampled everyone. And this sampling regimen here of sampling a large population, like sampling, going out and asking people how they're going to vote, you're taking a small sample of a massive population, and the good analyses of that have to include a randomization of who you're picking. And this is the reason why these polls are not working very well anymore, is because they're unable to get a good random sample. They're calling people, for example, and on the phone, who answers, who has a landline, number one. If it is a cell phone, people are not going to just answer a random call, which looks like spam. So they have to call, sometimes I was just hearing they have to call for 2 hours before they get one interview. And so they're not getting a random sample. They're not able to sample everyone. So first of all, if these are the ballot numbers, and they said they have them in reverse order here, first of all, if you did think that this was a thing over time, why would you do it in reverse order? If you did it in the other order, what it would look like is that, you know, it would be, it wouldn't look this bad. Like, oh, Trump, they act like it went way up for Trump and then it converged down here. That assumes that this is time. And first of all, these ballot numbers are not ordered according to the time. So even if you thought you were putting them in the opposite order, they're not. So when these ballots come in from the voting machines into, say, an ES&S voting system, and they said this was Mesa County, I'll tell you what, let me pause quickly here and we will go and get that data. Okay, so I just jumped over here to Verified Voting website, and I think it'd be useful for you to see this. If you go to the verifier, you can find out what equipment they actually have. And he's talking about Colorado and Mesa County. What do they have? They have Dominion voting systems. Okay. Dominion voting systems uses a batch and a record ID number. So the batches, and it's also very much a vote by mail kind of a community. How these ballots come in and vote by mail is what I call arbitrary. It's not random. And there's a difference between random and arbitrary. The ballots come in, and let's say this was in the right order that they were coming in. You can have, it's well known that people who vote earlier or vote later may be vastly different in their voting, you know, basically the split between the parties, for example. Early versus later can be quite a bit different. So you can't say that it's random over time if you, and they're saying it should fall within this cone here because it's random, but it isn't random. It's somewhat arbitrary. In other words, which ballot exactly is going to be assigned to these numbers is going to be based on factors that are too hard to describe. Okay, so many factors in terms of how it's going to be routed through maybe the mail system, if it had to be cured, the signature had to be repaired on it. All these factors that are very complex, but not random. So, and also which voters vote early versus later it could be skewed by party and so forth. So those things, there's so many factors involved. It's hard for our mind to model how those factors would all line up. But that doesn't mean it's random. That means it's a complex function, but not a random function. And so even if it's complex, it may have quite a few biases in them as they go along. And that's the main thing we want to understand here. Just because something seems arbitrary doesn't mean that it's random. If you did randomly sample this without having any aspect of time, then it would have to fall within whatever the random cone is like this. If you did a good job of random sampling it, that's just the law of those random numbers. If you're not random sampling it through this somewhat complex and arbitrary system that we're not aware of what the complexity is, then it might go off. And it might, go off quite a bit. This is because to some, and it depends on the voting system. In this case, Dominion and a state which does a lot of vote by mail voting, it's going to come in and be batched up. And a lot of times the batch numbers are according to the different scanners that are used. So this tabulator is the first number, then the batch number, and then the final record number. And the tabulator number is not they're only gonna use this tabulator first, and because that's the most significant digits of the number in the ballot ID number. So these are not ballot ID numbers, how they're shown here, and how they've decided that these came in this order, in this case reverse order, which would be completely a bad way to look at it. And then when they turn this around and put it in the other order like that, so apparently it looks like this is the ratio, and some of the ballots that came in really early, and then later it started to converge this way. That means that this somewhat arbitrary way that these ballots were being processed is not random. If it goes like this does not mean that there has been manipulation. So if you the whole idea of trying to find manipulation would be that we have a way of random sampling this, such that there is the method of random sampling makes it so that it should fall within this range. And therefore, anything outside of that range will be due to some effect that we are looking for. And when you see analyses like this, sometimes what they do is they'll take, say, the precinct number of an area. Well, the precincts in a community might start at the top, and they have a grid where they go down somehow through the community, and there might be a big city, and they hit those, and then they continue down where they're in the rural areas. So you would get a lot of maybe more conservative voters at first, and then you'd hit this and you would look like there's a lot of liberal voters in the city, and then more conservative voters. And so that's how you would number them. Or if you do it by size, which I've seen in the Tim Canova analysis by Phil Evans, what they were doing was ordering this by the size of the precinct. And then they would start with the smallest precincts first, which wouldn't have much impact, and then move along until they got to the very large precincts later. And then they would add those in and would look like it was having a big change at the end. So this situation here, where they're starting to have, say, an average down here, but then diverging from it, means that you don't, in fact, have a randomization. Now, the fact that these people are not correcting for that means that their analysis is completely shot. The idea that this is time, and they said and they say later in the election, isn't the case. That the ballot numbers in the cast vote record will go from 1, 2, 3, 4, and these are the earliest ones, and then the ones with the highest numbers are the later ones. That's not the case. In fact, it's a law that all of the ballots have to have this in a certain tranche. Like we have to consider, of course, the early voting. We know which ones those are, and we know the election day, and the ones that were like voted by mail but not processed until after the election because there was some delay in getting the signatures analyzed, for example. So we have different tranches of ballots, and then finally there's the provisionals at the very end. So there's really 4 tranches, and the difference in the margins can be substantially different. In San Diego here, we noticed that the very first tranche, which was the earliest early vote by mail ballots, and this was between Hillary Clinton and Bernie Sanders that they were looking at, we had the more conservative voters who voted very, very early. And they're all Democrats. And we saw that Hillary Clinton was like 58 to 42 to Bernie Sanders, landslide victory for Hillary Clinton. Then the election day voters were about 50-50. And then after the later vote by mails, the ones that were dropped off at the voting centers and or maybe mailed at the very last minute, those were processed after the election, and those had Bernie Sanders far in advance, say 58 to 42, just the flip. So it was looking concerning to us, but we had to realize that these different times, different tranches could be quite a bit different in how they were processed. Within a tranche, within, say, the in-person voting, the ballot numbering in the cast vote record has nothing to do with the time that they were cast. And so to say that this is what happens over time, the same with the early versus later, like they have a whole bunch of ballots from early voting or the early vote by mail ballots that came in. Those are all sort of, they're kind of arbitrarily put together into batches, and you don't know what these batch numbers are, whether they're earlier or later. So as I was saying, first of all, within, say, the election day voting, those ballot numbers are randomized to some methodology, and sometimes resorted into precincts and other things before they're assigned a number. So you can't say this is an earlier ballot or that's a later one. Furthermore, they don't have a timestamp. They're required to have all exactly the same time. So you don't know when the ballot was cast. So these charts that are shown here, and this is at the Ordros website, they do look at some other ones which are like the margin for precinct and different things that might be more valid. But essentially, when you hear them, they're saying over time. Like let's listen to this one segment here.
This graph shows instances of large blocks of votes for one candidate or the other, and should be analyzed using both ratios of the candidates.
Okay, so when they say large blocks of votes, those have already been sort of arbitrarily put into these blocks. They are not blocks that have occurred due to a random process or something. So they're not truly random. So they're put in an arbitrary way with a complexity that we don't actually know how to follow.
It shows that very Trump-heavy blocks are seen towards the end. The raw votes page displays a graph showing the raw number of votes for each candidate over the course of the election.
So he says over the course of the election. These numbers here, and I'm not sure, this may be the offset of the cast vote record within the entire cast vote record set. That's completely divorced from when it was cast. It could be that there was a tranche earlier and later, as I was saying. And therefore you would, if you did have not random, but you had, like in this case, more of the votes were barely, it looked like it's about 50-50 for each one. But then as the course went on, that means you're getting, including ballots from the different tranches. So if you had, say, the later vote by mail ballots, the latest ones that were deposited, those we found tend to be the more Democratic or liberal leaning voters, as opposed to the more conservative, the people who said, I'm going to vote really early. But it isn't quite that way anymore. It's tending to be that everybody is being told vote early and get your vote in early.
Counting. The vote percentage page shows how much of a candidate's eventual votes they have gained at any particular point in the election counting.
Any particular point. And sometimes they had these ordered backwards. So you can't say, okay, well, this is diverging here because at this time we're getting more votes in, because it's not necessarily related to time. And if they do a precinct ordering, which is what I saw in the Tim Canova analysis, I think by Phil Evans, there they ordered them by the size of the precinct. And the size of the precinct might be small in the rural areas and then larger in the central cities. Hard to say what is the order, but there could be a tie to what kind of voters you're getting in. And then you're going to see, oh, that looks weird, because if it was random, it would fit within that cone, and it's not fitting within the cone. And so therefore they're saying, okay, they did this in the reverse order for some reason. Why would you want to do that? If it was time, you would want to look from the earliest time to the later time. What they're doing is doing it in reverse order. Well, first of all, there isn't an order of time here. So you can't say this number, and I'm not sure how they came up with this number here. We'd have to do some more research to find out. But what is the number? And what is this? And then what is the reason that you're choosing that number? If you're going to choose completely randomly from this entire set, then it would and it should fall within this range. If you're not choosing randomly, then it may go out of the range, true. But here what they're saying is they're saying this is according to time, and that isn't true, because the cast vote record numbers are not according to time. And it's the thing here that I like to say is it's an arbitrary correlation. It's a correlation, a function that you don't really know, but you can't say it's random. And when you say it should fall within this range because it's random, I don't understand it. It's so many factors, it must be random. That doesn't mean it's completely random. It means that there's just a lot of factors, and they may add up such that you will diverge like this in this time. So just wanted to go over that because there was so much confusion. And honestly, I've spent what was a couple of hours on the phone the other day. And I wanted to, when I saw this, I wanted to make sure that I was able to present this. We can maybe look into it, get a few more examples, but I wanted to just hit this quickly so you would have this information. Okay, this is Ray Lutz. I'm with Citizens Oversight. We do have an auditing application called Audit Engine that does help us check exactly with the results from the ballot images to the final result. Okay, thanks. At citizensoversight.org. Please like and share the video. Bye now.